Hi, I'm Mr. Huber, and in this video we're going to talk about exercise 39. An observer B is situated 70 meters above sea level. So this is sea level, this is your observer, 70 meters above sea level. The angle of elevation to the top of a mountain is alpha 28 degrees. So when you look up to the top of the mountain, it's 28 degrees. Its mirror image, S dash, is seen under the angle of depression of 35 degrees. So you have the sea here on sea level. Then you can see your mirror image of your mountain in the sea. Okay, so that's down here at an angle of depression of 35 degrees. So this is going to be D, the height above sea level, and this is also going to be D, because your mirror image, when you look in the mirror, and this is your nose, then you look at the mirror and you see your nose back here. So same thing here. So you look from here up to the mountaintop, you look into the sea, and you can see your mirror image down here. So what we're going to do now is the following. We're going to produce this line, and we know this is 70 meters above sea level. So if this whole thing is D, then this is D minus 70. And this down here is D plus 70. So let's highlight that. So this part here is D plus 70, and this red part here is D minus 70. Because from here to here it's 70, so you add to your distance D the 70 meters. You subtract to your distance, you subtract from your distance D the 70 meters. So now we're going to set it up like this. We're going to say tangent 28 degrees is opposite D minus 70 over adjacent, well, this is the adjacent, L. And for the other one, you're going to do the same thing. Tangent 35 degrees here is D plus 70 opposite over the same adjacent, L. So now let's isolate L. So L tangent 28 degrees is D minus 70. So L is going to be D minus 70 over tangent 28. Because you have two equations in two unknowns, so you're going to isolate one of the two. Here you can do the same thing. It's L times tangent 35 degrees is D plus 70. Then L is D plus 70 over tangent 35 degrees. Now you can set them equal to each other. Okay? A system of two equations in two unknowns, D and L. Tangent 28 and tangent 35 are just numbers, but well, they're difficult to handle. That's why we leave them as they are, because tangent 28, that would be, let's see, tangent of 28, that would be something like 0.5317 and so on. So we just leave it as it is. Now you can set them equal to each other. D minus 70 over tangent 28 is equal to D plus 70 over tangent of 35. We need to isolate D. So for that, we need to get rid of the fractions. So we multiply everything by tangent 28 times tangent 35 in order to get rid of the fractions, which is in fact a cross multiplication. So tangent 35 D minus 70 don't forget the brackets, is tangent 28 d plus 70. So you multiply times tangent 28 times tangent 35. The tangent 28 goes and the tangent 35 remains. Same thing over here, just reversed roles. So you multiply this part here, this term by this term, so the tangent 35 goes and you will be left with tangent 28 degrees. So now look, this is just something like 5x minus 70 is equal to, let's say, 3x plus 70. What would you do here? Well, you would multiply it out. You would say 5x minus 350 is 3x plus 210. Then you would add the 350. So that would be 560. You would subtract the 3x. That would be 2x. So x would be 280. Okay? This is exactly what we're going to do here. But we're working with tangent 35 and the numbers are not that as easy as 3 and 5 here. So tangent 35 times d minus 70 times tangent 35 is equal to tangent 28 d plus 70 times tangent of 28. You could work these numbers out, like 210 and 350. But well, the problem is these will be complicated decimal numbers and we want to leave them as they are. So now we added the 350 on both sides here. So what we're going to do is we add this term on both sides. And we're going to subtract this term on both sides. So tangent 35 d minus tangent 28 d is equal to 70 times tangent 28 degrees plus 70 times tangent 35 degrees. Okay? Well, unfortunately, this is a complicated term. You could work it out. It would be something like 560, but well, a completely different number. But over here, you have a problem because look, 5x minus 3x, that's just 2x. Well, let's have a look at this. 5x minus 3x. Well, you could write 2x for that. But 5x minus 3x, you could also write 5 minus 3x, which is also 2x. Okay, so that's something you can do here. Tangent 35 minus tangent 28. So you factor out your d. This is now a number like 2, but well, more complicated. And over here, you're still left with 70 times tangent 28 plus 70 times tangent 35. So now you divide by 2. So we divide by these brackets. So d is 70 times tangent 28 plus 70 times tangent 35 divided by tangent 35 degrees minus tangent 28 degrees. Okay? So the good thing about this is the exact value. Okay? If you had worked with approximate values, you would get an approximate value here. But this is the exact value. So let's type that in now. So fraction 70 times tangent 28 plus 70 times tangent 35 divided by tangent 35 minus tangent 28, the exact value. You're going to get d is approximately equal to 580 11.78, which is roughly 512 meters. So the height above sea level is 512 meters. So let's do a quick recap. So we had to understand our drawing. I gave you a very mathematical drawing. In the exercise, you see the mountain and you see the sea level where this mountaintop is mirrored in or reflected in. Well, here, this is a mathematical drawing. It's easier to work with. So you could say tangent of 28 is d minus 70 over L, so opposite over adjacent, and here also opposite over adjacent. You isolate L, you set them equal to each other, and you work it out. It's not too difficult. I hope it was understandable, and I'll see you in the next one.